trunculus has these glands which, when you take them out, we crush them, we dry them, and this is what we have here, basically powdered snail glands. And I'm just going to pour this on my fingers and turn them. Okay. So, what you see here, if you look closely, is not much. These glands don't dissolve in water. That is the trick that needs to be solved. You see, dyes in general are very, very hard to come by in nature because it's really something of a tautology that doesn't make any sense, right? You don't want your dyes to wash out. They have to be inert. They can't come out of your fabric with water or with soap, right? But that means that they're very self-contained. And if so, how are you ever going to get them to bond to the shirt itself, the fabric? That's why dyes are very, very rare, and people say that the history of chemistry is essentially the search for dyes. Everything else was simply learned along the way. We're going to add a couple of chemicals here that are going to help this dye dissolve in water. The chemicals that we have, you'll all get a press kit, and these things will be explained a little bit. What we're essentially doing is modern chemical magic that's going to allow these dyes to be dissolved. I'll get that in 1 second. And the other one first, if you could, Joel. And essentially, what you'll see is, hopefully, that we start to get the dye into the water. Something is now going to be coming out. I'll just let it boil for a second. What you have here is a dissolved color, a little bit green, which means that at least something is getting into the water. And that's what we wanted to do. I'm going to take a couple of seconds to explain what exactly is going on. Inside, I need it. Okay. So, what we are going to do basically is we're going to put the wool in, I'm going to move it into the sun, and after that we can explain what's happening. Again, all of the chemical explanations are going to be using the dye kit. Great.
At what stage it explodes?
What?
At what stage it explodes?
Hopefully not at this stage.
Okay, just wanted to know.
Okay. Now the smell that you're smelling, hopefully, is part of the story. I'll get to that in a second.
If you want to know why we decided to do this outside, now you know.
When we dye our Tekhelet for ritual purposes, at this point everything has to be done specifically for the intention of dyeing for the specific commandment, and we'll always say, before we put the wool in, l'shem mitzvah tzitzit. That's an important part of our process. I'm going to put this in the sun now. And while that's baking, let me explain to you what's going on. Inside the snail, there are 3 different molecules. There's an indigo molecule. Indigo, anyone wearing jeans? Yes. That's the indigo molecule. It's blue. But there are 2 other molecules that are purple color. They have bromine atoms attached to them. The distribution inside the snails is much more dibromo indigo and monobromo indigo than indigo. And that's why you get this purple. What we've just done now, John, you get very much. What we've just done now is the following. I hope you can all see this. It's not obvious. We started with a purple molecule, dibromo indigo. What we did is a chemical process called reduction. Okay, and at that point, if you look on the side, everything changed color to a yellow color. In 1985, partially because of this incredible smell, the researchers who were doing work on this, Professor Otto Elsner was one of them.